what do you mean by CMOS logic? What do you mean by CMOS logic circuits? Well, my name is Rishi Remju. Welcome to the Backbench Engineering Community. I make engineering easy for you. So let us ask yourself this obvious question. What do you actually mean by the term CMOS logic? Well, let's find out. So CMOS logic circuit. This is a type of logic circuit that we can design with the help of two transistors. One is an NMOS transistor and the other one is a PMOS transistor. So with the help of NMOS transistors and PMOS transistors, we can design any particular function. This is simply what you refer to as CMOS logic circuit designing. That is, a CMOS logic circuit, it is made up of two types of transistors. One is an NMOS type transistor and the other one is a PMOS type transistor. So with the help of NMOS and PMOS transistors, we simply get what you refer to as a CMOS circuit. Let me make that even more simple for you. So here, we know that an NMOS transistor looks something like this. Here, it will have a gate terminal over here, it will have a drain terminal over here, and it will have a source terminal over here. This is an NMOS transistor. So here, what we know for a fact is that when the gate voltage is 0, that is, whatever we give at the gate, if that is 0, then this becomes open. That is, this particular transistor is in the off state. So if this transistor is in the off state, it means that there is no connection over here. That is, there is no flow of current between the drain and the source because it is open here. So therefore this, in the case when 0 is given at the gate, this acts as an open circuit. But rather, when we give 1 at the input, at the gate terminal, what we observe is that this is now in the on condition, and therefore there is a flow of current between the drain and the source because now it acts as a short circuit between D and S. So therefore it is short circuited between the drain and the source. So this is the case of an NMOS transistor. Now let us see what you refer to as a PMOS transistor. So here, in the case of PMOS transistor, we have something like this. It is the same as this, but here there is a circle like this. This represents a PMOS transistor. Here we have the gate, but here we have the drain, and here we have the source. So in the case of a PMOS transistor, what we observe is that when we give 0 at the gate like this, here it means that this particular switch is in the on condition, and therefore because this is on, it is short circuited between the drain and the source. And now when we give 1 at the input at this particular gate terminal, this particular switch is in the off condition, and therefore it becomes open circuited between the drain and the source. So now it is with the help of these two transistors we create a CMOS logic circuit. As simple as that, guys. As simple as that. We just take one type of NMOS transistor and we take another type of PMOS transistor and we connect it in multiple different ways, and thus we achieve whatever circuit that we require. That is simply what you refer to as a CMOS logic circuit. So now there are different ways or different rules which we have to follow in order to create or design a particular CMOS logic circuit. So in that, this is how we create a CMOS logic circuit. First we would have the VDD on top. Okay, so first we have the VDD. Now we would have a series of transistors, that is a set of transistors over here. This set of transistors is what you refer to as the pull-up network. And this pull-up network is entirely made up of PMOS transistors. And now from this, again it is connected to a set of transistors over here, and these set of transistors are referred to as pull-down network. And this pull-down network is made up of NMOS transistors. and this is now connected to the ground. So here, with the help of a pull-up network and a pull-down network, in which this particular pull-up network consists of PMOS transistors and this particular pull-down network consists of NMOS transistors. So with the help of these two networks, that is how we create a CMOS logic circuit. And here, in between these two, we would now take a required output like this. This is simply how we create a CMOS logic circuit. So now, the one thing that you have to keep in your mind is for a fact that whatever output we get over here is the inverted output. Say, let us assume that I am creating a circuit, a CMOS logic circuit to perform the function, say, f is equal to a dot b. So now I have designed the CMOS logic to get f is equal to a dot b, but when I get the output here, this would be a dot b complement over here. So now what I have to do is that I have to now pass this through an inverter to get whatever desired output I need, that is a dot b. So this is simply how you design a CMOS logic circuit. So now there are certain rules that we have to follow. First, in the case of AND operation, that is the dot operation, the PMOS transistors are connected in parallel, whereas the NMOS transistors are connected in series. That is in the case of an AND operation. But in the case of an OR operation, the PMOS transistors are connected in series, whereas the NMOS transistors are connected in parallel. So these thus are the basic rules with which we can create CMOS logic circuits. As simple as that, guys. As simple as that. So I hope you guys now have a clear understanding of what you refer to as CMOS logic circuits. And if you guys found this video informative, please do hit the like button and join this community by hitting that subscribe button. We'll be discussing about the further topics in the upcoming videos. So stay tuned, stay subscribed. Until next time, I'll see you guys in the next video. Thank you.